There are lots of different types of numbers that we can use to describe things, like a length of a line segment. We can use numbers like 1. All right, so that has a line segment of 1. These are whole numbers. If we try connecting two dots of these line segments, we can have whole numbers. We can have fractions. We can have decimals. Numbers that we use often are whole numbers and decimals and fractions. But what about lengths like this? What if I have a line segment that goes down 2 and over 2? How long is that line segment? Well, we have to use a Pythagorean theorem there. We can see that if this line segment is c units long, we know the Pythagorean theorem says c squared equals 2 squared plus 2 squared. And that gives us 4 plus 4, which is 8. And if we square root that, we see that c is the square root of 8. Well, what is the square root of 8? Well, that's a number that is not a whole number. In fact, it's a number that written as a decimal, it never ends and it never repeats. Sorry, let's make that an 8. All right, so the square root of 8 is a number. The length of this line is the square root of 8, which is about 2.828. But it's not exactly. All right, well, we can see that when we find square roots here, or we find lengths like we did in this activity here, the question here is, what are all the different lengths that we can find within a 5 dot by 5 dot grid? Well, if we go a slant like this, let me redraw this one. Well, that one there is the square root of 8. Okay, kind of down 2 over 2. If we go just down 1 and over 1, that's going to be, if we do the Pythagorean theorem, that comes out to be the square root of 2. And if we do this whole length here, this comes out to be the square root of 32. Now, look at the lengths here. See this line segment? That's kind of going at a slant down 2 over 2. Well, that's the same length as this guy right here, which is also the same length as this part right here. So this line segment, which is a square root of 32 long, is twice as big as the square root of 8. So if we take 2 times the square root of 8, that's equal to the square root of 32. Well, you might also notice that this square root of 2 here, that's kind of at a 45-degree angle, down 1 over 1. Well, that's the same length as this line segment right there. And this one right here also. So this square root of 8 is made up of 2 of these square roots of 2. There's one of them there, and there's one of them there. So those lengths are the same. So that means that 2 times the square root of 2, I don't know what the square root of 2 is, but if I have 2 of them, I have a square root of 8. All right? And we found some other ones in here. Now we know the whole number ones, like 1, well, let's say 2 times 1 is 2, and 2 times 2 is 4. Okay, that's nice. But what's interesting is these ones here. Now notice this. What's going on? What's the difference between these two? Well, 32 is 4 times 8, and 8 is 4 times 2. Okay? We also found some, if you look into those dots more, you'll also find the square root of 20 in there, and that's 2 times the square root of 5. Notice the connection here? That 20 is 4 times bigger. That 8 is 4 times bigger. That 32 is 4 times bigger. Okay? Well, where's that 4 coming from? Well, the square root of 4 is the same as the square root of 2. So we're seeing that the square root of 4 times the square root of 5 is the square root of 20. Oh, well, that kind of makes sense, right? Okay, now we're going to talk more about this multiplication. So square roots. Square roots are the lengths of squares, or sides of squares. The side of this square, if the area is 1, then the side is the square root of 1, which is 1. If you have an area that's 4, then the side is the square root of 4, which is 2, because we know that 2 times 2 is 4. And 1 times 1 is 1. But what if we have 2? Well, the square root of 2 is a number that we are not very familiar with. But there has to be a number, because if you ever want to make an area that has, or a square that has an area of 2, you've got to have a number that's the square root of 2. And whatever that number is, when you multiply it by itself, or when you take the square root of 2 and you square it, you get 2. So that is what defines the square root of 2. So let's go back and let's look at what's going on here with this pattern, and we're going to talk about products of square roots. So let's look at some products here, all right? I want you to take a moment, go to a calculator. You can pause the video real quickly. Go compute. What's the square root of 4 times the square root of 5? Punch that in a calculator or into Desmos online. That works. Then punch in the square root of 20, get a decimal. Punch in the square root of 4 times the square root of 25, get a decimal. Square root of 100, see what you get. Let's see what our Desmos calculator has to say. So if we do the square root of 4 times the square root of 5, we get that number there, 4.47. Whoops, come back. If we do the square root of 20, we get the same thing. Oh, that's kind of interesting. What about the square roots of 4 times the square root of 5? Oh, we just did that. I'm sorry. Square root of 25. Well, let's do that. Well, that's 10, a nice whole number. That's interesting. And the square root of 100 is also 10. All right, so what's going on here? This was about 4.47 here. Both of these were. And the decimals were exact as we saw. This came out to be 10, and this came out to be 10. Well, notice that 4 times 5 is 20. And 4 times 25 is 100. So when we're doing this, we could either put them together and then square root, or we could, looks like, well, we know the square root of 4 is 2. We know the square root of 25 is 5. And, yep, 2 times 5 is 10. All right, so this leads us to what we call our radical product rule, okay? And it says this. It says if we have 2 square roots, these are also called radicals. This symbol right here is called the radical symbol. All right, that is radical, dude. All right, so if we have 2 square roots, we can multiply them and put them together as 1 square root. Like this. If we have the square root of 2 times the square root of 5, well, that's just the square root of 10. I don't know what the square root of 10 is, but I took 2 square roots and put them together as 1. If I have the square root of 2 times the square root of 32, well, I can put that together. 2 times 32 is 64. And oh, what do you know? We know what the square root of 64 is. That's 8. So sometimes when we multiply and put them together, you can't do anything with them. Sometimes you can. Well, that is how we put 2 square roots together. But what if we want to pull them apart? Okay, so let's think about this. What numbers can we take the square root of easily? Let's think about the perfect squares. Perfect squares are numbers that we know the square root of, all right? So let's find all the positive numbers. Well, I know 1 times 1 is 1. Square root of 1, I know. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, or 4 squared. 5 squared is 25. 6 squared is 36. 7 squared, 49. 8 squared, 64. And 9 squared is 81. And 10 squared is 100. Okay? And so on and so forth. So these numbers you want to be real familiar with. These numbers we can take the square root of easily. So you've had experience with those in the past. So when we want to simplify a radical, sometimes we can just take the square root because we know them. The square root of 25, we know. The square root of 49, we know. But a radical must be simplified if it's not a perfect square? So here we have a number square root of 18. How do we simplify that? Well, what we're going to do is this. We're going to simplify the radicand. There's a funny word. The radicand is this number underneath. We want to factor it into two things that include a perfect square. So we have the square root of 18, and we think through these. Which one of these numbers goes into 18? 9 does. So we say this is 9 times 2. Is that true? Yeah, 18 is 9 times 2. According to our little rule there, we can break that up into the square root of 9 times the square root of 2. I don't know what the square root of 2 is, but I do know what the square root of 9 is. That's 3. So this is what we call simplified. Okay? So 3 times the square root of 2 is the simplified version of the square root of 18. We kind of took the square root of part of it, but not all of it. This is exact. It is not rounded off, all right? Okay, so then let's try a few here. If you want to pause and try them, you can. Square root of 50, well, that's the square root of, is there a perfect square that goes into 50? Yeah, 25 does, right? This is 25 times 2. So we can break it into the square root of 25 times the square root of 2. Do we know the square root of 25? We do. It's 5. So that is 5 square root of 2, and that's what we call simplified. What about the square root of 32? Is there a perfect square that goes into 32? Look through your list or think through your list. 4 does, but keep going. Get the biggest number. The biggest number is 16. So 32 is 16 times 2. So we break this up into 2 square roots, and we get 4 square root of 2. There it is. So we can square root the first part. Square root of 16 we know is 4, but we can't square root the second part, so we leave that alone. Okay? Well, one more here. What if we have two things being multiplied? Well, if we have two things being multiplied, we got to put them together. That's the square root of 24, and then break it back apart. What perfect square goes into 24? Well, I think 4 does, right? 4 is a perfect square. It's in our list. That's 4 times 6. We know the square root of 4. That's 2. And the square root of 6 we don't know, so we leave it alone. And that's how we simplify radicals. Okay? One more step that we'll use, one more thing is, well, what happens when we have a fraction? When we have a fraction, we don't want to leave radicals in the denominator. That's a bad idea, all right? So we want to simplify these by rationalizing the denominator. So what that means is I want to get rid of this square root of 2. Well, how do we get rid of square roots? You might want to square it. You might think, let's square both sides, the top and the bottom. Well, unfortunately, you can't do that to a fraction. Once you do that, the fraction's not the same. But what we are allowed to do is we're allowed to multiply the top and bottom by the same number, because we're really just multiplying by a 1. Well, what would you like to multiply this by to make it a whole number? We don't want square roots or irrational numbers in the denominator. Well, let's multiply it by itself, the square root of 2. But if I multiply the bottom by the square root of 2, just like all fractions, like we've done before, we've got to multiply top and bottom by the same number. What happens here? Well, the bottom, square root of 2 times square root of 2 is the square root of 4. The top is just 6 times the square root of 2. We can't put that together because this is under a square root, this is not. So we leave that alone. Ooh, I think we know what the square root of 4 is, right? The square root of 4 is 2. Okay? So we have 6 times the square root of 2, all over 2. And we got a little further. Sometimes we stop right here, but notice this. Okay, those two numbers can be simplified. We can divide 6 by 2, which is okay to do because they're outside the square root. 6 divided by 2 is 3. And the square root of 2 just comes along for the ride. And so we end up with an expression. This had a square root in the denominator. This one didn't. If you plug both these into your calculator, you'll get the same value. Okay? Let's try a couple more. How about this one? Well, let's try the same thing. I don't want the square root of 2 on the bottom, so I'm going to multiply top and bottom by the square root of 2. Really, I'm just multiplying by 1. Square root of 2 times the square root of 2 is the square root of 4, which is 2. And the square root of 5 times the square root of 2 is the square root of 10. Leave that alone. You can't do anything. Don't try to divide these because this one's under a square root, this one's not. We can't divide them if they're not both under square roots. Okay? All right, one more. What do we want to multiply by now? Well, it's not the square root of 2 on the bottom, it's the square root of 6. So multiply by the square root of 6, we get 2 times the square root of 6. There's a times there, it's invisible. All over 6. And we can do a little bit of something with these guys here. Okay? We can simplify those. 2 6 becomes 1/3. So 1 times the square root of 6 all over 3, and you don't really need this 1 there. And that's it. Okay? So rationalizing the denominator gives us an answer that does not have an irrational number in the denominator. All right, that's how we simplify radicals. We'll work with that. A very useful tool for any advanced math from here on out.